Great. Thanks so much to, let me see if I can close this down. Hold on, let me see if I can get rid of these. There we go. We really want to thank Jack and Tom for inviting us. This is what Jamie and Eileen and myself look like in our normal professional lives. It's a little different when we're teleworking, although I think I'm wearing the same shirt today as I'm wearing in this picture. We really want to emphasize that this is a tag team presentation. So the three of us are just sort of the tip of the iceberg and the kind of work that we're going to talk about today. We're going to talk about a few of the most recent initiatives around 3D at the Library of Congress. I'm going to talk about our in-depth research and evaluation of common 3D formats, especially for data modeling. And Jamie and Eileen will cover a recent project which implemented some of the formats that we're going to talk about. So one of the real drivers for this work was our interest in our 3D work was surrounding a project that I helped organize about a year and a half ago. Called Born to be 3D, and there's nothing like organizing a big public event around something you don't know to bring you up to speed quite quickly. So I don't know if I would recommend that to folks, but it was really helpful for me. The library at that time didn't have a lot of in-house experience or robust 3D collection content, and to a certain extent we still don't, with some domain, like we do in geospatial, but not in some other places. So we organized this event to use what I call the gravitational pull of the Library of Congress to act as a community hub to explore, promote awareness, and plan for the long-term stewardship of Born 3D data for research and cultural heritage. And the forum focused on the shared needs of 3D data and data management for geospatial and especially the built environment information, and the use of this data in fields like archaeology, digital humanities, and affiliated communities. All of the speaker presentations are available, as well as the shared community notes at that super easy to remember URL. But it was really this event that got us connected to the community. And when we heard what folks were doing, what they were interested in doing, and our file format research grew from there. So the really not so secret goal of this meeting was capacity building for within the Library of Congress, especially for senior leadership. And it was really a way for us to say, like, there's a whole world of content out there that's coming, and we need to skill up with our understanding, but also with our resources. And, you know, when you're the world's largest library, and I'm doing air quotes right now, when you're the world's largest library, it's easy to forget that we don't know a lot of things. And so this was one of those reminders, and I would say in that it was quite successful. So most of my work at the Library of Congress focuses around research and development supporting digital file formats. Like, my standard joke is that I don't actually do anything at the Library of Congress. Like, I don't work with collection material for the most part. When we get a new acquisition and that's got some funky files that people don't know what it is, they call me and I help them identify what it is, but I don't otherwise deal with collection materials. And we have a number of resources around digital file formats, including something called the Recommended Format Statement, which doesn't yet include specific formats for 3D and design, but a spoiler alert that is planned. The thing I'll talk about today is one of my main projects, which is the Sustainability of Digital Formats website, which analyzes in depth the technical aspects of digital formats. And we right now have, you know, it's depending on how you count, somewhere around 480 formats sorted into content categories, which include things like still image, sound, textual, moving image, web archive, data sets, geospatial, and generic formats, with more to come, but especially 3D. And it's been our main focus for the last 2 years, I would say. So important features of these format descriptions, including documenting relationships between formats, and the factors to consider when evaluating formats, including sustainability factors and quality and functionality factors. And I'll talk about each of those in just a moment. This resource is geared towards strategic planning for digital content. We're now in our 11th year, and we're still going strong. I'm proud to say that we still get anywhere between 35,000 and 50,000 unique visitors every month. So that's great. Our primary focus is on formats that are in the library's collections or otherwise of interest to the library for a variety of reasons. And I often get asked if we take requests. And generally the answer is no, because my list is long and time is short. And it typically takes about 40 hours or more of research to write a format description. So we definitely need to prioritize. But that being said, we always welcome comments. So certainly if you see something, say something. And if you say something, it comes to me, and I would be delighted to hear from you. So as I mentioned, our 3D formats, a lot of that, the interest in that came out of our Born to Be 3D work. When we realized what a great variety of 3D formats were out there. So the research and the documentation of those has been a major focus for the past 2 years. Here's a sampling of the new descriptions with the most relevance to this community, but there's also all sorts of 3D capability in adjacent communities, especially geospatial, and even document-based formats like OpenXPS and PDF, which is everyone's favorite format. And I haven't yet pulled all the 3D ones together as a specific content category, but it's on our list of projects for this year. And I know Chronos is coming up next, and we have a couple of evaluations of GLTF. And I'm happy to say you guys got pretty much thumbs up, so that's great. And I'm excited to hear the Chronos presentation. So this slide highlights the categories of information that we research, sometimes exhaustively research and document. My standard joke when I give this kind of presentation is that I read the RFCs or the standard specifications documents, so you don't have to. You know, the one for PDF is over 1,000 pages long. Well, let's take a look at one of the format descriptions that we're talking about. And in this example, we're going to look at OBJ, which is FDD 507, and FDD is a format description document, so I may use that throughout this talk, and that's what I'm talking about. And they all follow the same naming pattern that you see there in that URL. So FDD's a couple of zeros and then the number, and they're just sequentially numbered. There's no reason for the number. I know some of them by heart, but in the first section, which is called description, we typically cover the technical structure of the format as defined through the specifications. And in our typically understated way, and that is a sarcastic comment because we are nothing understated in this resource, we talk about not just what the specification says, but also how it's implemented and the ramifications of that implementation. So we don't just necessarily trust what the spec says. We try to triangulate it to our documentation. And it's important to say that we don't always have sample files, although we do try to get them. So we often have to rely on what's published. And this is especially important when specifications are behind paywalls. And we know that folks don't have access to that, but we do. So we try to summarize as much information as we can without getting in trouble, and have those features all available in one place. And we have an extensive list of references for each format, and I'll show you just that in a minute. So relationships are hard for lots of reasons, but it's one of the things we're most well known for. And it's perhaps the most challenging things to establish sometimes. So we document not only file formats with a file extension, with a known file extension, but also all of the versions of that format to the extent that we are able, as well as all of the things that can go inside that file. So if we're talking about a wrapper, we'll talk about all the codecs that can go inside that wrapper, and then how they interact with each other once they're all in there together. You could take a look at FDD 30030 for PDF, and you'll sort of see what I mean about how complex those relationships are. But let's just stick right now to OBJ. So OBJ, if we follow this along, you'll see that we have a bit of a nested relationship here, a dependency here. So OBJ may have MTL files. So of course we had to do an FDD for MTL as well, but MTL files can only exist inside OBJ. And so that's a dependency that you may not recognize, but if you see those files, associated in whatever group of materials that you're getting, it's helpful to understand how those two things interact. We have two types of evaluation factors. There's actually a third type, which I'm not going to talk about today, but that's really the practical factors about what happens when we digitize. But So the sustainability factors were quite well known for that. And I'll just take a break in my professional development here and say that my cat is now running around, and I had hoped to show her to you, but she's not. Oh, there she is. So she may pop up and you may see her. So anyway, if you hear a little bit of scratching in the background, that's what's happening. So sustainability factors apply across all of our digital formats, and they would be significant whether preservation strategies entail things like migration to a new format, or emulation, or a hybrid of migration and emulation, or normalization, whatever you'd like to do. And these include things like disclosure, adoption, transparency, external dependencies, self-documentation, impact of patents, and technical protection mechanisms. Quality and functionality factors, however, pertain to the ability of a format to represent the significant characteristics of that current category. And these factors vary by genre. So for still images, we have things like clarity for high image resolution or color maintenance, support for graphic effects, topography, and support for multispectral bands. But for 3D, we have developed these quality and functionality factors, and we're certainly interested in feedback on this. And so these come from a paper in 2008 from the National Center for Supercomputing Applications. And according to their analysis, the key aspects of a 3D model format are geometry, appearance, scene, and animation. So when we're talking about OBJ, how these things line up for OBJ, you're not expected to read this, of course, but it's helpful to note a few things here. So I'm not sure if you pronounce this as NURBS or NURBS, but either way, it's the most common freeform surface technique for geometry, and that there's that potential dependency on MTL for color and texture. So that's interesting to know. I see all kinds of things in chat, but I have your chat blocked. So while I'm talking. So if I had to choose a favorite section, like a favorite child, although I only have one child, so it's really not hard, but it would be identifiers, because nothing makes me happier than opening up a file in a hex editor and chasing these things down. So as you all know, the file extension is just one type of identifier, and I would argue it's the least stable identifier, but there are many, many more. And here are what we have identified for OBJ. And we definitely link up to other format projects, including Pronoma Wikidata. It's really quite interesting because sometimes our research doesn't agree, like what we have and what maybe in Pronom doesn't agree, but we always share. And I also should mention that all of our FDD work is available in both HTML and XML, so you can download the data as individual FDDs or the whole set as a zip drive. And we are the Library of Congress, so we are all about the references. We don't come to play. And I shrunk this down as far as it would go, and I still couldn't get all the references that we'd use for just OBJ on this one screen. But suffice it to say that we have an extensive, we do extensive work when we do these format resources. And there's that scary note again that says my connection is unstable. And we do try to keep things relatively updated. We had most of our stuff in a web archive. We had the largest archive at the Library of Congress. So also if you're in need of something, you could also let me know and I may be able to have that for you off the record. And what we're working on now is I've got about a list of 60 formats that are waiting queued up to be either written or reviewed. A lot of this work is coming out of new formats that we're getting in collections, but also work that's happening on our recommended format statement. So these are some of the things that we're looking at. As I listen to the talks from today, I realized we haven't really done any work on 360 video, so I may be reaching out to a couple of folks and sort of seeing what might be coming down the road there. It's not necessarily coming into our collections in any meaningful number, so it hasn't bubbled up yet, but that's what we're going to be looking for. So now I'm going to turn it over to Jamie and Eileen, so I'm going to stop sharing so they can start sharing.
Awesome. Jamie, do you still want me to share my screen?
Yeah, that'd be great. Thanks. Yeah.
Excellent.
Hi, everybody. I don't have a cat, but I do have a dog, and it's in a painting behind me, but it's not here because it's very loud. I put it upstairs. Thanks for having us. It's been such a fascinating day.
That look good.
Yeah. Yeah, I just want to say it's been such a fascinating day. My specialization in library school was digital preservation, but my career path has taken a different turn. So it's been really nice to hear about current developments happening in preserving media. So we're going to switch gears and talk a little bit about a 3D capture pilot that we did at the library. So this is just a case study and some things that we learned. So if we go to the next slide. So I'm Jamie. I'm from a team called LC Labs at the Library of Congress, and this is my colleague Eileen Jakeway helping me present. So we worked with a bunch of groups around the library. The way it works at the library, essentially, I'm sure with lots of organizations, is that when senior leadership wants investigations done of technologies or products, et cetera, a working group will sometimes get formed to evaluate and produce a report for them to review to decide whether or not they want to invest. So politically, they're really important because the end goal is basically to have a choice of whether or not resources are going to be put to the approach. And they end up having a lot of cross-organizational buy-in, which is really nice, especially when you're learning together. So the goal of the working group, it started out as basically a curiosity around 3D printing, actually. We have a very robust education and outreach division at the library, and they were curious about deeper engagement with learners on site and also remotely. But it grew from that very, very quickly into looking at 3D capture as a way to more broadly share items that we have in our collections. And you can see here that the goal, I thought this was important to include, doesn't necessarily include preserve. So we did choose a capture process, photogrammetry, that Eileen's going to talk about with long-term preservation in mind. And we are including preservation recommendations in our report. But the entire lifeline of this pilot is only 2 years. And because of that, we are not sure whether or not we're going to keep the files that were rendered for the project. So we basically were curious about what is it like to do capture in-house? What kind of objects do we have? Will people engage with them, etc. I also want to mention that we do a lot of pilots in LC Labs, and I always am curious to hear from folks like what magical things align to actually make them possible. And so I like to always mention the environment. So there's no mystery. This pilot really only was possible because one of the working group existing and having this cross-organizational buy-in, as I mentioned before. And then we also have a experimental site hanging off of loc.gov called labs.lsc.gov. So we had a space where we could publish the 3D items that we created without them having to be formally indoctrinated into the Library of Congress's collections. We also had a very, very specific target user group in mind, which was students and teachers. And we've spent many, many years through education and outreach and other groups at the library forming relationships with that user group. And then most importantly, we have a mentor relationship with Smithsonian 3DX team, Vince Rossi and his team, which are right down the street. There was some money already for our digitization team to do training last fiscal year. And so the money for actually paying for a 3D capture to happen on site and train all of us noobs on how to do it was possible. Next slide. So the process has been really long. It's been over a year at this point, and the pilot will conclude in October of this year. It might be extended because of what's happening right now with the virus, but officially it's supposed to end in October. And we started by doing research, looking at formats, looking at preservation-friendly forms of capture. We identified and selected objects around the library, which was harder than it seems because we are not a museum. Most of our holdings are books and manuscript material, but we do have a lot of really, really fascinating 3D objects that most people don't get to see when they come and visit. So we spent a lot of time kind of collating a list of those. And then the biggest amount of time was actually the contract part. We ended up contracting with CHI, the Cultural Heritage Imaging Group, and it just took a long time for bureaucratic reasons. And then when the training happened, it all very, very rapidly accelerated into a really fun, I think, successful pilot. So Eileen will take over from there and talk to you about what that capture looked like.
Awesome. Yeah. So before we start, thank you all for having us and listening. I'm learning so much, and I'm excited to share about LOC 3D, which is the name of our pilot. So I'm coming at this from the perspective of a staff member on LC Labs who was selected to sort of participate in the training and then see this pilot through. So at the start of this process, I was a complete novice in photogrammetry. And now I actually built one of the models that I'll show you at the end with our demo. So I'm going to talk a little bit about the process we used to build these models. I'll end with a high-level overview of the sort of files that we created that I think might be useful. There's Kate's cat, yes. And then I'll end on a demo, just showing you the 2 objects that are live on our website now. So I know that some of you have maybe been trained by CHI or worked with CHI before. So if you have, you know that image capture is sort of the first and very important step in the photogrammetry process. They specifically taught us a workflow and a methodology to ensure that we achieve 9 look angles on any given part of a subject and a 66% overlap between each photo taken. And I thought I wanted to kind of focus on this a little bit, that even though image capture, processing, and post-processing are all really equally sort of vital parts of the process, I found that if we were going to actually create like a visualization of the process that was representative of the amount of time and resources that are involved, for us at least, this middle part, processing and actually building the products, was the most time intensive. And so for someone like me, who was a complete novice, image capture took maybe around 2 to 4 hours, kind of being trained by CHI. But then once they left and I was left to build the model all on my own in Agisoft Metashape Pro, which is what we were using, it took me about a whole week's worth of time to sort of troubleshoot and end with something that was presentable and could be put online. And I know that's sort of anecdotal evidence, but I think it's really kind of worth pointing out that it's not just sort of like, oh, and all of you know this, but you take some pictures and then you plop it in the software and then you end with a 3D model. It's a lot more sort of idiosyncratic, and we really had to take a lot of steps to adjust to each individual, the sort of particularities of each object that we were capturing. So again, I apologize if this is information you already know, but I found it really useful in giving presentations to other library staff to talk about sort of the steps that we took, that we were sort of taught in a very regimented and structured workflow by CHI. So you start by aligning your object and building a sort of sparse cloud, trying to get those pixel neighborhoods to match up in virtual space. And then you go through a series of optimization steps to kind of edit away any stray points that you don't want sort of built out in the final model. And so this picture on my left, maybe you're right, was really kind of useful to illustrate what can go wrong in the alignment steps. So I was building out James Joyce's death mask, and actually the mask sort of aligned to itself when I was first trying to get it to build out. And so I actually sort of worked together with the Smithsonian 3D team to use markers to sort of tell the software where to actually put the points. So that was just kind of a funny example. Yep, so I'll gonna very quickly go through these. So once you kind of have a sparse cloud that really seems to be quite good, you build out a dense cloud, which essentially just fills in the polygons between the virtual points in space. We were told to build out the mesh from there using the dense cloud as your sort of source data, and by mapping the texture back onto the dense cloud the mesh that you had created. And so that's what we did. That's what I did when we're doing this, this death mask. And one of the things that really struck me as someone who was a beginner user was the amount of processing time that it actually took to build out each of these various products, and the amount of time that you then lost when you realized that you made a mistake earlier on that you hadn't seen until you actually like spent the time to build the model, or sorry, the either the dense cloud in my case or the mesh. And then yeah, here's just another sort of example of like when I built out a dense cloud that like had a bunch of stray points in it that I clearly did not need to have built. So for this group in particular, I thought it would be really informative and maybe interesting to talk about our post-processing workflow. So with Agisoft, you have lots of options for sort of exporting in a variety of files, and those I think really depend on the use case. So we talked a lot with CHI, and we worked very closely with the Smithsonian team as well as our in-house developers to think about the use case that we were going for the purposes of the pilot. So CHI was sort of very adamant that if you ever wanted to sort of serve this file, these models to researchers, that it was really important to sort of try as much as you can to serve the original project file. But for our purposes, which was to have a web viewer available to the public and also files for 3D printing that could easily be downloaded, we decided to go with a GLB that was significantly downresed and an STL file. And these parameters that we got for sort of decimating the mesh came from one of the sort of leads on the Smithsonian team. And here are the three that he sort of said were best, especially for using their 3D open source viewer that we did end up implementing on labs.lsc.gov. It is worth mentioning back to kind of what Jamie was talking about at the beginning of the talk, that the archival files are DNGs, and that is sort of baked into photogrammetry as a process that even if none of the derivative files that we created in this pilot like are ever used again or are able to be used again, the original DNGs will allow people to kind of apply a similar computational and like mathematical approach and end up with something that looks the same as what we had built now, but years into the future. Yeah, and I think these are, yeah, the .psx was the project file that we had within the software itself before exporting it. Yeah, so I wanted to kind of move from here into our demo. So I'm gonna X out of this and go here. So if you go to labs.lsc.gov under experiments, you'll find one titled LOC3D, and that's where you'll be able to see these two objects. You may notice that James Joyce did not, in fact, make it, which is one of the key learning points from this was that one of the objects, namely Joyce, actually was sort of under copyright, specifically for 3D, because the artist added hair to his death mask, which constitutes an original creative work. So that was a fun lesson to learn, and we were guided by OGC that the estate is very litigious, and to avoid putting that online. So I wanted to talk about the cast of Lincoln's hand because it's slightly more interesting than the vellum manuscript. So here you can see it displayed sort of as a 3D object in our viewer. This was adapted by the Smithsonian team. The only things that we really changed were here, if you click on this icon, you can get the metadata file. And in the original viewer, that sort of dispelled the image on the left, and we thought it would be cool for people to be able to see this more as a drawer so that people could read the information while still having the object in sight. And then we changed the logo to be the Library of Congress logo, and we updated the share button with kind of all of the features that we could support, which is Twitter and Facebook. And yeah, here, oh, this is maybe worth mentioning, the STL is right here for people to download. And then we also linked and put them up on Thingiverse, because that's where a lot of our audience, namely educators, would go to find them. I think that's it.
Very cool. Thank you very much, guys.
Thank you.
So yeah, I'm going to open up to questions. I noticed there was one in the chat already from Fergus. I'm not sure if does Fergus have audio, and do you want to ask your question?
Oh yeah, hi there. Great presentation, super interesting. Particularly like the information about OBJ files. I was just wondering, you mentioned there was an open source viewer for 3D files. Which one would I be looking at for that, please?
Yeah, it's called Voyager, and it's the one developed by the Smithsonian 3DX team. It's available on their GitHub repo, and I'll see if I can find the link and put it in the chat.
Great, thank you. Yeah, I saw Voyager mentioned. I just wasn't quite putting the two together. Yeah, that's very helpful. Thanks a lot.
Absolutely.
Yeah, you're getting a lot of love there for your work, you guys, on the chat. So thank you so much. That was amazing.
Sure. Does Chris King have a hand up?
He's had his hand up
Or was
all
that from
day,
before?
so
Yeah.
I
Oh,
don't know if he has
maybe he
loads
just
of
accidentally-
questions or
You must be
no
really
questions.
tired.
Yeah, right. I asked him earlier on. I noticed his hand was up.
Okay.
I actually have a quick question. It was really nice to see this
Oh,
kind of
Says he
photo.
doesn't have a question. Okay.
It was really nice to see this kind of photogrammetry shaped gap in my understanding get kind of filled out a little bit more there. You mentioned you might not keep model outputs from the photogrammetry work you've been doing. What would be the essential things to keep from a project like this? So you mentioned these DNG files and there's JPEG files as well as working files, but I wasn't quite clear on what you would need to keep and the different roles of those things.
And this is Jamie answering. So the only thing that we're actually, turn my video on, because it's a pilot, the only thing that we're actually required to keep, that we're reporting to keep, is the resulting report in and of itself, not the objects. Of course, we could, and it's highly likely that will happen, but resource-wise, we're not making a commitment to that. It was literally just to go through the process ourselves to see whether or not this is something that we want to build out as a program at the library.
And I forgot to mention.
Eileen, you want to go ahead?
Yeah, I was just going to say, I forgot to mention because I got too excited about the demo, but we are writing a report about sort of summarizing the findings and documenting lessons learned and sort of recommendations that will be released. The public version of that will be released in the fall. So I think that'll probably be our final deliverable that then gets passed on to sort of decision.
I will say in our sustainability digital formats website, we have a section called production phase, and then we categorize, especially for 3D, if it's for like initial capture, or if it's for data storage, or if it's for printing, so that we don't make a judgment about which one you should. We tell you where in the workflow would this format fit, so that could also be helpful.
Cool, thank you.